What if the most advanced telescope ever built has just revealed something humanity was never supposed to witness? What if all of our long-held beliefs about the universe's origins, about time, space, and reality itself, far unraveling in the face of new, undeniable evidence? The James Webb Space Telescope, created to observe the earliest light in the cosmos, has now delivered data so disturbing that a Nobel Prize-winning physicist has spoken out with a chilling statement. This is not our universe. But what exactly did Webb discover at the farthest reaches of existence? And why are scientists warning that these findings could rewrite the foundations of cosmology itself? What you're about to learn could change everything. In a seemingly unremarkable corner of the sky filled with ancient starlight, the James Webb Telescope captured what appeared to be a simple yellow blur. But upon closer inspection, astronomers were stunned. Their assumptions collapsed. But that tiny glowing smudge wasn't just another distant galaxy. It was the most remote galaxy ever observed, formed just 290 million years after the universe's supposed birth. And yet it shouldn't exist. It's too massive, too bright, and far too evolved to have formed so quickly after the Big Bang. According to current models, there simply wasn't enough time or matter in the early universe to create such a structure. But there it was. It wasn't alone. The James Webb Telescope has now found dozens of similar galaxies, each one defying established theories. These cosmic anomalies are rewriting everything we thought we knew about the early universe. Digging deeper, scientists found even stranger phenomena. Some of these early universe objects aren't just massive, they're unlike anything previously observed. While normal galaxies convert about 10% of their gas into stars, Webb detected at least 3 galaxies that have turned 100% of their matter into stars. No gas, no dust, only blazing pure starlight. This isn't just rare, it's considered impossible by every existing model of galaxy formation. This has led to a far more unsettling question. What if these aren't galaxies at all? What if what we're seeing isn't the early universe, but something else entirely? Could they be remnants of a previous universe, structures from another dimension, or even intrusions from a parallel cosmos? To understand why this is shaking the scientific community to its core, we must consider the concept of the Hubble sphere and the observable universe. The further an object is from us, the faster it moves away due to the expansion of space. A certain distance called the Hubble sphere galaxies move away from us faster than light itself. In theory, we shouldn't be able to see them, and yet we can. This paradox is possible because space itself is stretching, which expands the boundary of what we can observe. However, beyond that boundary lies something even more disturbing, a region of the universe that can never reach us, and that we can never reach. Despite this, the James Webb Telescope is now picking up light and signals from these impossible zones light that should never have made it to us. This leads to one astonishing conclusion. We may be seeing beyond the edge of our universe, and no one knows what lies beyond. Webb's data has forced scientists to entertain previously unthinkable ideas. What if the universe never had a beginning? Some Nobel Prize laureates are now openly challenging the Big Bang model. If galaxies can form faster than physics permits, if light can arrive from beyond cosmic limits, and if massive structures appear that defy our understanding of time and scale, then perhaps we've misunderstood everything. Maybe the early universe isn't early at all. Perhaps what we're observing is not a chronological timeline, but a fracture in reality, a place where 2 universes overlap, or something unimaginably old is leaking into our own. Whatever the explanation, these phenomena do not fit into any known model of cosmology, perhaps never will. Among the James Webb Telescope's most intriguing and overlooked discoveries is not a visual observation, but a strange frequency. While measuring the background hum of the universe, Webb's instruments detected a faint rhythmic pulse, something unlike any known cosmic signal. It wasn't a pulsar, nor gravitational waves, nor a distortion of the cosmic microwave background. This mysterious frequency repeated with precise regularity, almost as if it were generated. Some astrophysicists have dubbed it the heartbeat beyond time. Others suggest it could be the signature of exotic matter, something that could only exist beyond the boundaries of our universe. Even more unnerving, the pattern isn't random. It follows a distinct mathematical structure, suggesting it may have been intentionally encoded to be discovered. Another unexpected finding is the growing mismatch between what the telescope detects visually and the gravitational effects it measures. At extreme distances, galaxies appear to exert enough gravitational force to bend light, warp space, and influence surrounding structures. But the matter causing this gravitational pull is nowhere to be seen. This isn't just dark matter, it's something else entirely. Webb may be detecting vast gravitational anomalies that don't correlate with any observable mass. These phantom forces behave like invisible fingerprints pressing down on space-time from a realm we cannot perceive. Where are they coming from? Some theorists now propose something once considered fringe. We may be witnessing the influence of a parallel universe colliding with our own. What if everything we perceive has a physical mirror counterpart we cannot detect, not metaphorically, but literally? A once dismissed theory is gaining new attention, suggesting that a mirrored universe exists where time flows in reverse and physics operates in the opposite direction. What changed? The James Webb Telescope has gathered evidence such as asymmetrical particle behaviors and rotational anomalies in far-off galaxies that hints at the presence of two overlapping cosmic systems. It's as if our universe is being pulled one way, while another, just out of reach, moves in reverse. If this is true, we may not be alone in the multiverse. We may be entangled with a shadow realm that reflects and interacts with our own in ways we are only beginning to understand. In a final, deeply unsettling twist, one of Webb's long-range instruments was tracking a distant light signature near the boundary of the observable universe. Scientists expected it to fade into darkness, as most such signals eventually do. But instead, it reappeared not from the same location or time, but with an identical spectral signature. It was as if the light had bounced off something. Webb may have captured what's being called a cosmic echo, but an echo of what? There are only two possible explanations. Either the light looped around the curved shape of a finite, closed universe implying space has an edge, or it struck something else, something reflective at the very edge of everything. That should not exist. The James Webb Space Telescope was intended to look back in time and reveal the origin of our universe. But instead, it may have unveiled something far more terrifying. Its discoveries: the impossible galaxies, phantom gravitational fields, mirrored cosmic patterns, mysterious rhythms, and cosmic echoes are dismantling the illusion that we understand our place in the universe. That Nobel Prize-winning physicist was not speaking in metaphors when he said, "This is not our universe." And perhaps that's the truth we were never meant to confront. Maybe we are floating at the edge of something far older, far larger, and utterly indifferent, hidden structure, a deeper layer, a universe behind our universe. So now the real question isn't whether we're alone in the cosmos, it's whether